Welcome to YouTube channel scientific underscore math. Our main topic is solving a system of linear equation, and the learning objective is in previous lecture we have discussed the Gauss elimination method, and in this lecture we solve example related to the Gauss elimination method, and in next lecture we will write a Matlab code for the Gauss elimination method using the backward substitution. Gauss elimination example. So we have a system of four system of linear equations, equation 1, 2, 3, and 4, and the equivalent matrix form is this one, that is Ax is equal to B. We can also solve by using the this matrix form, the Gauss elimination method, and we can also solve by system of equations. So we take both forms in system of equations, and the matrix form we solve both these step by step. Okay, so in first step we eliminate the terms that including the variable x1, okay, except the equation 1, and here we take the augmented matrix, and that is AB, and AB is equal to this one. Okay, so we know that this is the uh, pivot equation, and this one is the pivot element, and we eliminate all the matrix elements and that are below the 4, that is minus 6, 1, and minus 12, and we convert this into the upper triangular matrix, so yeah, our upper triangular form, and we eliminate all the elements that are below the diagonal entries. So in first step we eliminate terms all these terms except the equation 1. So step 1, the equation 1 or the row 1 is unchanged, and the terms that include the variable x1 in all the equations or row are eliminated. So multiply the equation 1, we multiply equation 1 or row, that is the pivot equation or row, with minus 6 by 4, that is equal to minus 5, minus 1.5, and then subtract second equation or row. Yes, so here, okay, so we multiply this equation by minus 6 by 4, okay, minus 6 by 4 equation 1 or row 1. Then we subtract equation 2 minus equation 1, and similarly row 2 minus row 1. Okay, so after this we get this one in row 2, this the terms including the term x1 is 0, and next we get this one plus 4x2 plus 2x3 and plus 3x4 is equal to 11.5, and we can see that in matrix form, and the term below the element below the leading element or the diagonal element is 0. Okay, so in the next step we multiply equation 1, okay, equation 1 by 1 divided by 4, or equation 1 or row 1. Okay, so multiplying equation 1 or row, that is the pivot equation or row, and in here we have next the next pivot equation is this one, okay, and similarly when we eliminate this term, then the pivot equation becomes this one, and when we eliminate this one, the equation pivot terms will be this one pivot equation. So with 1 by 4, that is 2.5, and subtract third equation or row. So after subtracting, we get this one, okay, and the term that including the equation that including the variable 1, and that is eliminated. And here we can also see that, and the term, the element that is below the diagonal element 4 is 0. Okay, so next, multiplying equation 1 or row, that is the or row with, okay, next we multiply minus 12 by 4, and we multiply with equation 1, and we subtract we subtract from equation 4 or equation 4 or row. Similarly, we multiply with row 1, okay, then we subtract minus 12 by 4, multiply row 1 minus row 4, okay. So then we will get this one, this element will be 0, and here the term that including the variable x1 will be 0. Okay, in next, the step 2, what we will do, we will eliminate all those terms that include the variable x2 except equation 1 and except equation 2. Now we eliminate these terms, and these terms here, these elements, and these elements. Okay, so the step 2 equation, the second equation or the row is the pivot equation, or row unchanged, and the term that include the variable x2 in all the other equations or the row are eliminated. So next we multiply the second equation or the row with 8 by 4, and subtract from the third equation or row. So here we eliminated the term that including the variable x2, and here we eliminated in the element entry that is below the diagonal element. This is the diagonal element, and we have eliminated this element, and next we eliminate this one. So next we multiply 16 by 4 with R2. Yes, multiply the equation second or the row with 16 by 4, and subtract from the equation 4 or row. Yes. Okay, so here we have eliminated the terms, this one that include the term x2, and this one, and the element this one. Here we can see that this is the 0. Okay, so this is the step 3. Next we the third equation or the row is the pivot equation or row unchanged, and next this equation, this one and this one will not change, and only we eliminate these terms that is below the diagonal element, this one. Okay, so next we multiplying the third equation or the row with this one, and subtract from the fourth equation or the fourth row. So here we can see that the term that include the variable x3 is eliminated, and here we can also see that the term that is below the diagonal element is eliminated, and we get the upper triangular matrix, upper triangular form. Okay, so now uh, we find the values of the unknowns x1, x2, and x3 and x4 by backward substitution, and we write this in ax is equal to b form, and this is our the Gauss elimination method, and now we find the values of the unknown. Okay, once the solution is in the form, the solution can be determined by backward substitution. If we are solving the system of equations by matrix form, then at this step we multiply all these elements to this one to again obtain the equation form. Okay, so Now by backward substitution we find the values of the unknown. First we find the values of the x4. Here we can see that the x4 is equal to 2, x4 is equal to 2, and then similarly we find the values of value of x3, and then similarly x2, and then x1. So uh, uh, we get x1 is equal to 2, x2 is equal to 4, and x3 is equal to minus 3, and x4 is equal to 2. These are the values of the unknown x1, x1, x2. And in the next lecture we will write a Matlab code for Gauss elimination method with backward substitution.